And I would like to warmly welcome our first keynote speaker, Professor Derk Loorbach from the Dutch Institute for Transitions to join us today. And Professor Derk Loorbach is also the director of the Institute, and his background is in socio-economic transitions at the Faculty of Social Sciences at the University of Rotterdam. And he is one of the founders of the transition management approach and the kind of new forms for sustainable development. So we are eager to hear what you have, what's your messages for us, Derk. Are we on the right track with this renewal? And how does this sound to you? Could you kind of like, how would you advise us to move further and then kind of where to start?
Yes, thanks so much for having me, and big congratulations to the selected teams. I think you're on the right track, but I'm not so sure if you have the right sense of direction. And hopefully that's what will become clear also in my presentation, that I think the insight that technology is maybe not the right starting point for thinking about the societal challenges that we have is the right one, but that will inevitably also imply that you need to rethink how you do research. And in the three proposals, I still hear a traditional research approach. So hopefully after my presentation, we can spice it up a bit with some transformative elements. I can see I can share screen.
Yes.
Let's see if I manage.
And we have reserved something about 30 minutes for Derk's keynote speech, and the idea is to have questions and answers and the discussion after Derk's presentation. So please.
I thought I'd go for this mode, but now I'm in front of the slide, so I have to see how that works. But I'm experimenting with the new technology. Good afternoon, Derk Loorbach. Thank you for the great introduction. The founder of transition management. It sounds like I founded something. I have to change it maybe in my resume, but I have been working on this topic for 23 years right now. And I will explain a bit where it came from, this idea of transition and transition management. Partly my main job is with Drift. It was nicely introduced. It's a strange entity. It's a social enterprise of our university. And our mission is to develop knowledge in and with practice in order to advance sustainability transitions. The second affiliation that I have is that I am a lead of a platform, an initiative, a strategic initiative at our university, which tries to explore or research the transition of the university. And I will bring some of those elements in because I think it's also a relevant discussion for VTT, also as became clear from some introductory conversations that we had. My background, and this is start with a few slides from this platform I'm leading. Together with colleagues, we try to reflect upon the role we have as researchers in sustainability transitions. And we refer to it as transformative research. And the starting question really is, how is it possible that with all this knowledge that we produce as researchers that we have so little transformative impact? We might have to rethink how we produce knowledge and how we address these societal problems. And before you know, this is also work that a colleague of mine, Julia Wittmeier, is working on. We need to have a conversation about our roles as researchers. It's obviously to gather data and to make analyses, but more and more we see that we as researchers also have a role in bringing people together. in stimulating debate and social learning processes, in creating interventions. So the whole of my presentation is framed in this way. I use the term research, but for me, it's more broadly about academic work, because in our work at the Erasmus University, but I think that's no different for you. There are always elements where you develop knowledge, where you interact with your environment, and where you transfer experience and knowledge. So those three activities that are also at the heart of what a knowledge institute or a university or an institute like VTT is, they need to be aligned, and they also reinforce each other. So what we work with, and I throw it in here for the conversation maybe later on, is that transformative knowledge organization is really flexible in and adaptive in how it develops its knowledge in and with practice. Okay, it will become clear from the examples that I'll give later. If there are questions in between, I cannot see it, so someone has to intervene or just hold them for the end. So the sustainability transitions research community, it started 2023 some years ago in the Netherlands, Western Europe. By now it's a worldwide network. I hope some of you also are member or joining activities. The interesting thing for me, it's bringing together a very different communities. A very dominant stream of research in the network is the socio-technical perspective. Most famous is the multi-level perspective, and a lot of it comes from the history of technology and studying patterns of path dependency and lock-in related to technological choices. It will come back. Then we work a lot with people that have a more ecological or environmental background. We refer to it as socio-ecological. Think of resilience studies. A lot of work has been done there on planetary boundaries, on tipping points, and on the dynamics of change in complex ecological systems and how human intervention influences that. My background and where we position ourselves as the drift more is in this socio-institutional space where we look at patterns of transformation more as social learning processes that are always highly political and controversial. The emphasis between these different approaches slightly differs, but at the heart we are interested in these patterns and mechanisms of system change. So that's the analytical side of the research network. On the other hand, we are interested in these patterns of system change, obviously because we want to understand how to accelerate societal transitions. And that brings in the question of agency. Again, there are very different ways to think about agency in transitions, in a very analytical or maybe more evaluative way. Does policy work, for example? We at Drift, we do it in a more experimental way. But whatever approach, it always comes back to what is the role of actors in slowing down or accelerating and guiding transitions. So things that come up here are the role of power and of discourse, visioning, experimentation, and so on. So the field is very broad and eclectic. Maybe it's not even a field, but the interesting thing is over time, we started to accumulate a lot of insight and deeper experience with these kind of patterns of system change, but also how to influence them. The origin of the whole field is this very fundamental question that every researcher should ask himself: how is it possible that this insight into unsustainability, so the fact that we are producing and consuming in a way that destroys our environment and creates a lot of social economic inequalities while we're at it, is well known and well documented for decades already. Society responds to some extent. So we make sustainability policies, we make climate agreements, we do all these experiments and projects. But if you zoom out, basically we are still on the same crash course. So I like this figure because it captures both the science on how bad things are, as are good intentions. Obviously, this is about the science policy interface. So how do we translate science into action? And I've been involved in a big exhibition in the Netherlands last year, where this was a starting point. This question was the starting point. And we looked back 50 years to the work of this group of people. Donella Meadows here up front. She was part of the group of modelers, Jürgen Renders, Dennis Meadows also there, that produced the limits to growth model. In 1972, basically this was already the outcome of scenario exercise they ran. So they made these, I think they made 12 projections. What would happen if we would see a continuous growth in the population and associated production and consumption. And what they basically predicted was around 2010, 2020, we will start to see the limits to growth, environmental disasters increasing and so on. And by 2072, we will have a global collapse because of food shortages, wars, etc. They mainly predict the worst case scenario in this graph, but as you see in this picture, we're basically on that scenario. So for decades, this is a well-known problem, and we've been thinking about it, and we've been trying to come up with solutions, but not changing the underlying structure of the problem. And these are some pictures from my city, but we see the same kind of pattern. And I'm sure that whether it's about energy saving or whether it's about packaging or about food, the three topics of the three projects, they are not new topics. You've been also discussing them in Finland for decades already, coming up with all sorts of good intentions and ideas, but somehow not being able to change the underlying drivers of the problem. So in my city, Rotterdam, the top right figure illustrates health inequalities. So depending on your zip code or where you're born, there are huge differences in life expectancy and health and health, but also when it comes to socioeconomic differences, poverty in our city, air quality, climate vulnerability. So there, if you start to look around you in society, you see this example of problems we are aware of, but are not addressing in a fundamental way. And the word that we use to start exploring why that is the case in transitions research is regime. And a regime is not meant in a political way. It's used in different definitions in different disciplines. So ecologists use it, demographic studies uses the term, physics. How we use it is to refer to the dominant and shared ways of thinking, organizing, and doing that we collectively develop in a societal subsystem. And a societal subsystem can be an organization. So my university or VTT has a regime, but we can also see it in a geographical area, so a city or a neighborhood, or in a social economic sector, like the energy system or the mobility system. And this culture, structures, practices, that refers to the amount to which the way we think, what is normal, what our shared values are, how we talk about things, relates to the way we have organized things, the technologies we've selected, the structures and infrastructures we've built and invested in, the institutional structures we have developed, the regulations, the organizational relations, the networks, but also how we behave. And people with social science background, they will recognize this idea of structuration. So the idea that we build these structures because they make our lives predictable and easy, and they make it more efficient. And these structures, they facilitate certain behavior, but also make that type of behavior easier. So, for example, at a certain point, we started to be able to afford a car. Every household, 1 or 2 cars. So we needed to start building roads, which made it easier to live further away from your work. But then if a lot of people do that, you get a traffic jam. So you need traffic management, and you need people to think about how can we use the road more efficient. But maybe also people start to argue that there needs to be more roads, or the road needs to be widened. So you get a sector that builds roads. And in this way, we in society develop regimes. And the characteristic of regimes is that, well, I said it already, they make our lives easier, but they also create a certain inertia and path dependency, because we have invested in these infrastructures, but also in a career. We've developed this routine, and our environment also accepts that routine and maybe even facilitates that routine. And everything is connected. It's very hard to escape from it. Even more so, most of the people take these regimes for granted, but by taking the car, still reinforce these existing regimes. So that's the sort of the analytical system perspective, but obviously it also relates to agency. I already said most people as consumers or citizens reinforce these regimes by just taking part of it, by turning on the lights, taking the car, buying packaged materials, and so on. On the other hand, we have professionals, researchers, policymakers, other types of professionals that have their career developed in this regime context. And what we started to witness more and more is that the way that we as professionals deal with problems in the regime, in this regime context, but also with innovation or progress, is in a particular way that almost reinforces these existing structures and cultures. And the 4 terms on the left here, obviously this is a bit of a joke, this picture, or a provocation. It's the G20 summit in Italy where they discussed climate. And they're throwing coins in the Trevi fountain for good luck. But they illustrate this mindset of rational planning. We refer to it as the implementation illusion, but a lot of energy and effort is being invested in processes where we negotiate towards agreements to set targets on the longer term and develop implementation programs, creating the illusion that actually somewhere someone else is actually going to do all that. But it's like a lot of effort in producing paper, and the comfort that we are really working hard on it while not actually doing something very practical. The second thing that we notice is that in a policy environment, but also in a business context, a lot of effort is put into reducing risk and to be able to predict or control outcomes of a process, of an innovation project, of a new initiative or an investment. So reducing the risk on the short term means you want to know what will come out of it. The paradox is that that pattern is actually making strengthening this path dependency and making the system as a whole more vulnerable. And then the third point is really also relevant for our conversation. problem solving is often addressed through identifying innovation. And there's a lot of evidence that innovation policy in general, technological innovation more specifically, is mainly serving to optimize or to reinforce existing regimes. And maybe we can come back later in the mobility example, for example, where it's so striking that we get electric cars, but not really a shift towards a completely new and shared mobility system. So the trap is here that we always think in terms of building something new and creating a new solution that is then added upon the existing, instead of thinking about what needs to go. And the last point is really a link to how we as humans have difficulty understanding exponential growth. So imagining that the world can be completely different in 10, 20 years is very hard. For an average citizen, but also for professionals that are so accustomed to the way things are. So this is just how it is. And we might imagine improvements, but a radical system change is very hard. At the same time, if we look back in history, there isn't a sector or a social system that didn't periodically go through this process of rapid reconfiguration. So for us, a transition is defined as the structural process of reconfiguration of a complex societal subsystem. And you can only recognize it in hindsight. So afterwards, looking back, you can establish this pathway and pattern of transition. And you need to understand it on a period of decades. So they are no overnight changes. They are on a day-to-day basis relatively evolutionary, you could even say. So there's a lot of examples in the literature. There are now hundreds of cases. Clockwise from top left, this figure illustrates different types of transitions. So Rotterdam, top left, that was bombed in the war. So the role of crises and conflict. Now think of the Ukraine or the Arab Spring. They can be a trigger for rapid system change. Or floodings. So environmental disasters in the Netherlands, floodings triggered a very fundamental change in our water management policy. Or the top right, Sikko Mansholt, he was a minister and later on the Euro commissioner for agriculture, and he revolutionized the Dutch farming system from very extensive small scale to very industrial, creating all the problems that come with it. Bottom right is the port of Rotterdam. It's an example of how entrepreneurs convinced policymakers to let them invest in expanding the port infrastructure in Rotterdam, and that created or made Rotterdam for decades the biggest port in the world. So that's an example of economic leadership. Bottom in the middle is the iconic picture of Fifth Avenue, full of horses and carriages, one car. And 10 years later, the same picture, you see only cars and sidewalks, traffic lights, pedestrian crossings. So it's a typical example of a socio-technical transition. And bottom left is a protest from the coal industry against natural gas in the Netherlands, where in the 1960s there was a sort of a public-private partnership where they worked together to shift in household energy from coal to natural gas within 10 years. So this very quickly, but for me this illustrates that there are very different ways transitions can unfold, and that agency plays a very important role. And what we learned from these historic transitions is that they are very different, yet also follow a similar pattern. And we tried to capture this pattern in this graph, and it's basically a pattern in which there are processes of buildup and breakdown that reinforce each other. So the context around these regimes changes. We call it the landscape, but it's demographic changes, environmental change, political changes, and it puts pressure on actors within this regime. So they try to innovate their way out of it. And by investing in more innovation, they also decrease the diversity in the regime, and more and more you will start to see internal tensions, maybe even doubt. And we refer to it as destabilization. It's basically the process where it becomes harder and harder to improve the existing, but people also don't really see the alternative. What happens on the bottom left in this picture is that very early on, people will start to explore alternatives, maybe become vegetarian in the 1980s, or refuse packaging already for 10 or 20 years, or invest in solar panels when they're still very expensive and don't work. But over time, obviously there are learning effects, so the alternatives become cheaper, but also the pressure on these regime actors increases, and then we often see triggering events, a crisis, a breakthrough. Well, think about the previous slide, and that can trigger this period of 10, 15 years where a shift towards a new future regime actually starts to happen. So we see a period of conflict and of chaos, but also emergence. So new principles are institutionalized, and that can lead to a future regime. In this process, obviously, also things disappear. Companies go bankrupt. We stop maybe eating meat every day. We stop using packages, or we stop throwing things away. So some things will disappear. At least that was the case in historic transitions. Why it is such a chaotic and a turbulent process is obviously because there's a lot of resistance against these transitions. There's a lot to lose. And that also means that a lot of people don't want to engage in this transition. On the other hand, there's a lot to lose for some, but if we move towards this period of chaos, there's also increasing amount to gain for more and more actors that have maybe started already 20 years ago to engage in transitions. So what we call transition governance is really trying to use a research mindset to try to understand what is going on, who is moving, and what the potential of this transition moment is. So it requires this more systemic view. We cannot know everything because these transitions are so complex. We cannot analyze or identify all the forces. So we have to accept uncertainty, but we can also trust that these underlying patterns and mechanisms are there. So, for example, we know that there are others that are already working on alternatives. So we might not be the ones that are needed to come up with the innovations. It's maybe much more a question, how do we create space for these innovations? How do we help to help them to diffuse and to scale? I see regarding time that I have only 5 minutes left, so very briefly go through an illustration of how we do that. For us as transition researchers, we always come into an environment or to a topic, and then the first question is, where are we? What is the dynamics here? And what can we contribute? So if the dynamics are that there's not a lot of urgency and the alternatives are relatively small, our contribution could be to start bringing in the long-term perspective and to start to reframe from the challenge from an optimization challenge and an innovation challenge to a transition challenge. So an example is a process that we did 6-7 years ago in Rotterdam. It was about the mobility transition, and we brought together civil servants and a lot of, we selected a lot of change makers in the city, and we organized this dialogue through which especially the policymakers became aware that their policy was mainly working to solve problems in the existing system. So what they did was mainly solve car problems. And in this transition arena dialogue, what became clear was that we needed as a city a socially inclusive mobility system, and we needed to think about the transition to a mobility system for everybody that also supports a healthy city. And in that process, the policymakers started to reflect on how they make policy, and they started to fundamentally change their policy routine, but also the kind of priorities they give. For example, in general, they shifted towards saying we need to create problems with the kinds of mobility that we like, for example, cycling traffic jams. And then if people start to complain, then the policy orders us to create more cycling lanes for bicycles, and that then attracts more bicycles, and then you get a path dependency that you like. Actually, our capital, Amsterdam, is now in that process, and there they say bikes are the new cars because there's too many bikes, but that's another problem. So in this context, when we start to engage with these social systems in this way and also start to identify these alternatives, we recognize that it's often not technology that is what is needed, but it's about changes in the social context, so behavior, but also the way we organize. And this concept comes from the European project that we did, which is all about trying to understand the pattern through which we change our local regime. And for example, in energy, so there's energy cooperatives as a way to produce and consume energy in a cooperative ownership model. There are initiatives like that across the world. They all use solar panels or wind energy, but depending on the local policy context or the people that are living together and involved in the initiative, the local climate, the funds or the resource available, every cooperative is different. And the interesting thing about this concept of this translocal diffusion is that can we identify sort of the generic ingredients, and can we then create platforms and mechanisms through which these ingredients can be transferred to other places and communities, but also that we can help the translation of these generic ingredients into a specific context. So this concept might also be interesting for, especially what I heard from the packaging and the food. If you think about scaling, it's from our perspective much more about facilitating the social learning, scaling deep out and in, as Michaux more calls it. So if we move on, we started to see more and more into context where actors within the regime start to feel the urgency and the alternatives become stronger, so the 2.0 phase. And in this context, we started to think more and more about this phase-out policy. So thinking, and then at least the policy mindset is maybe more open to address it, that inevitably we need to start to phase out or stop doing things. So what is the role of policy to adapt the regulations, transform the existing to make that happen? For example, internalize environmental cost in the prices, but also how to more systematically build up the alternatives. So we did a process like this in mobility. Was a bit later. We had not a small group, but 150 people. Oh, sorry for the Dutch here. And we could become much more specific about the transition that we wanted. So we set a target date, 2030, the whole city, all the mobility should be without emissions, but also inclusive and healthy. And we could identify, together with all sorts of change makers and companies and entrepreneurs, how to build up the alternative system, how to use regulation to change the existing, and and what kind of phase out to anticipate. For example, parking in streets, subsidizing fossil mobility, and so on. So we organize these processes as a sort of a joint fact-finding learning, but it's also a dialogue. We learn a lot about what's happening in a sector, but the process design itself also influenced the thinking of the people involved. And time is too short, but I can give a lot of examples of how involvement in this kind of a process changed and directly influenced also policymakers. For example, we now get a reduced speed in our city. I'll move towards an end because right now, and I quickly flip through it, we're moving into this transition moment. At least in the Netherlands, we see that in energy, in mobility, in food, there's so much evidence that we need to transform. There's so much policy engagement, and the urgency is not questioned, but the response is still more of the same. At the same time, the alternatives become much more tangible and practical and are almost already there. So what we say now is we need a much more forceful effort from research and design perspective to make these nature positive futures visible and tangible. So we call it backcasting, but we take as a starting point that the most desired transitions will lead us towards a future economy where we meet each other's our societal needs in a way that supports human well-being while restoring biodiversity. So in this exhibition I refer to, but in our work, we now engage with these kind of transitions. So local economies, I refer to cooperatives, but we can localize our economies much more and make people also owner of their local economy. In urban context, we need to phase out the private car. And with sort of fit for purpose mobility in a cooperative shared model, we can provide much more people access to mobility in a much more energy efficient and less resource intensive way, freeing up a lot of public space. We need to shift to a food system that is regenerative. So change our diet, the way that we produce. We need to build offices and buildings in a way that stores carbon with bio-based materials, that it generates energy. And we need to rethink how we, especially in the Netherlands, deal with our water defense infrastructures, not in concrete, but in a much more ecological way. I think I just have to end there, but what we try to do as transition researchers is try to analyze, but also use our position as researchers to then use that analysis to engage with the transitions that are emerging, and then be much more explorative and experimental by organizing these kind of dialogues, interventions, scenario buildings, to basically organize the collective search process that a transition is. Because, as I said in the beginning, we cannot innovate our way out of this crisis. It's to a large extent about rethinking and rediscovering how we organize our economy with new means. But the first assignment is to rethink it and to put social and ecological values first, to then do the backcasting and think about what is the technology that we need. So we don't need electric cars, but we need cooperative shared mobility systems in which all sorts of small and maybe some larger electric cars are also part of. But it starts with a social ecological challenge. Thanks for your attention.
Thank you, Derk Loorbach, for very interesting keynote speech that kind of like opens up very well the background of why do we need to understand and also kind of pay attention to the kind of social deep questions of society, of really trying to understanding our cultures and values and a way of kind of organizing ourselves currently. And actually we are going to make in the next week, with the help of Zeynep Falay von Flittner, an exercise with our teams, kind of like pointing out to the same direction Derk was opening up. So we are going to practice in the program of doing this kind of exercise of really kind of mapping the problems and the kind of understanding the transformations, and then trying to understand what is the role of technology to support that type of transformations. But hey, now we have, I would say, 10 minutes of time for questions for Derk Loorbach. And I kind of encourage you, we have some written down in the chat. I can read it for you, Derk. And if someone wants to make a question, you can also raise hand. And let's use like 10 minutes or so for the discussion in order to kind of keep with the time. But if I kind of read from the chat, Derk, to you the kind of the first question. Here's a question: how much the wealth or economic status of a country or a society influences their efforts towards sustainable transition?
Yeah, that's a complicated question. In general, the wealthier an economy is, the more unsustainable it is. So there's a very linear causality between wealth and environmental impact. Obviously, there are large differences between wealthy countries, of which some, like the Nordic ones, are more progressive when it comes to adopting sustainable development goals and embracing them as a hard part of their policy. I would say that in all cases that is not enough. So we have a very serious dialogue in the Netherlands where we have a lot of sustainability track record and policy, but we're still seeing it as innovation. And I think for me, it relates a bit to the second question. Maybe we can come back to it more later, but for me, it relates to the whole degrowth debate. So a lot of our national economies have evolved the way that they could because of a very extractive and also sometimes unjust economic model. So a lot of the Dutch economy is based on producing healthcare or food or energy in a very unhealthy and unsustainable way. So you transform or you translate nature into money, basically. And now we try to do the same, but then in a sustainable way. And I think that is not working. And that's the more fundamental insight that we start to see, that we cannot have a sustainable mobility system if we don't address private use of cars. And it also becomes very hard to make our energy system sustainable if we don't address how much energy we waste and how inefficient we use energy. Yeah.
But then the kind of the following question for that is that there's a question that I want to ask about the provocation of less technology is needed. Yeah. Would it be so that actually we need to kind of think that what could be the role of technology in supporting this kind of collaboration and thinking together, where should we go? So how do you see the kind of like the role of technology also in supporting these endeavors, that initiatives that we should take?
Yeah, so and I realize that my line of argument is also in a specific camp, or at least I'm taking a stand against the, for me, naive idea that we can solve the problems by becoming more sustainable without addressing how we have organized our economic systems. And so my plea for saying, okay, less technology is needed, is not saying, oh, we don't need technology, but I think it's much more fundamental to address how wealth and income is divided, and how we accept that nature is converted into money and value that is only for the ones that own things. So there are underlying mechanisms that we need to address that are more fundamental than a new technology. And the whole discourse of we need technological development is also part of that mindset and that frame that we can innovate our way out of it. It is also a diversion tactic, because then you don't have to question yourself, I will find a solution, or yeah.
But is then the following question, how do we understand actually innovation? Is that something, you know, you can consume, or kind of like there's a following question that we use the term innovation as something that is not commensurable.
Yeah, I think we need to have a lot more attention for exnovation, or for how we phase out, or how we stop doing things. I think that's a very highly underrated area of research. For me, obviously, it's still also about innovation, but then social innovation is more important. So how social, technical, and institutional work together.
Yeah, how do we find them?
But it's about but it's also so for me it's more important to think first about where we want to go, to be explicit about the long term, to then do the backcasting from which you're much more selective or precise about the type of innovation and what you innovate and why. And just in general, innovation is problematic.
Thank you. I suggest, I see Maija is there with the clockwise. Thank you so much, Derk, for such a nice and inspiring talk for us. It gives a very much food for thought. But now, agenda-wise, unfortunately, we need to go further. We have yet another very interesting keynote speech coming. And actually,
Simon had his hand up, so
exactly,
he can maybe start with his comment on
exactly, Simon Michaux, welcome. Maija has prepared to say a few words about your background, and then please do start with your comment, and then we move with your keynote speech.
Okay.
Thank you from my behalf.
Yeah, and so I would like to warmly welcome Simon Michaux next on stage. So he works as an assistant research professor in Geological Survey of Finland, GTK. And he has been recently talking a lot about energy and mineral blindness, the challenges and bottlenecks in green transition. So what are kind of the physical constraints of the scenarios that we plan, and is there a way out? So please, Simon Michaux, and actually you had your hand up, so if there is still something you would like to comment the previous one.
Well, it was a question for Derk, but then you then answered it. So the question was, how do you see energy dictating the shape and form of our systems? Because I've been looking at, for example, what is the circular economy, and how does it all work. And it every time we have a change in energy, the change in form of energy, that dictates the shape and flow of all industrial action around it. And we cannot have the same system that we have now if we're going to change our fundamental energy system, especially if their capabilities are so different. And I'm in the process of, the Swedish government's asked me to redesign the circular economy in context of my work. And what is coming out of that is a fundamentally different system than what's been proposed so far. It's a much, much smaller, and it's much, much simpler, less complex. So anyway.
Yeah, I tended to because I think I'm really looking forward to your conversation, because it's exactly what we also see. But the potential of new energy technologies is also the potential to revolutionize how we deal with ownership and involvement, and where the revenues and profits go. Obviously, that's a very highly political contest. So there's a lot of actors that want to keep these new technology, bring them in the old mindset.
The way I handle that is there's three basic pillars to what we're looking at. And there's the industrial energy technology sector. Then there is how do we interact with the environment around us. But the third one is the social contract. And that's what you're referring to there. And what I'm doing with my current work is I'm recognizing there's these three sectors, and all three need to be developed, and only then can we have the system in the middle that is our sustainable system. So I need someone who's a counterpart to me in the social sciences to come up with a social contract. And that's going to be a bar fight. Whoever does that is not going to have an easy time of it. So I'm just going to do the easy stuff, and that's the so all right, so how about I start then? If I may share my screen. Can you see that? Can you see the presentation?
Yes, we can.
Okay, rock and roll. So this is a summary of two pieces of work which are in the process of being published now. The full calculation stream of everything you see now is going into a peer-reviewed journal. So, all right, let's go. The challenges and bottlenecks of the green transition. So, why was this work done? I came from the Australian mining industry at a time when the Australian mining industry was being torn apart by the mining crash of 2012. China turned off their demand. And I came to Europe to learn industrial recycling. I came to Belgium, and I was learning sorting technology, and I was driving an dynamic fragmentation device. When I arrived, I was attending these H2020 meetings that were describing what the circular economy was. That was the first time I'd actually seen I'd seen the steady state economy before, but not the circular economy. But what struck me was the colossal amount of money that was being thrown around on vague platitudes, but there was no detail. And coming from the mining sector, where corporate management goes very quickly to some kind of project management, there was no credible feasibility plan for fundamental industrial reform that recognized the current physical industrial requirements to phase out fossil fuels. That is, there was no plan for industrial reform that actually recognized our current dependency on fossil fuels and our current dependency on minerals. And it occurred to me that in Europe in particular, we don't mine minerals here very much. We do in Finland, but it's not a primary industry. It's seen as like a bit on the side almost. And so there was no recognition of reality. In Europe, for example, we don't mine minerals. We buy finished products off the market, and that market appears. But this is also the case everywhere in the world. And there was a clear lack of hard numbers. Now, I knew from my time in Australia that large companies like Toyota were actually developing their own plans for the future, and they did have hard numbers, but they were keeping the information confidential. There was nothing in the public domain. And there was very little discussion about a current dependency on fossil fuels. Like most of our system is still fossil fuels. And what does coal do for manufacture? If we phase out fossil fuels, we lose most of our current manufacture capability at the moment, as it's done in China at this time. And since we don't manufacture much here in Europe in terms of components, that's going to be a problem. There was no discussion at all about our reliance on minerals. And the whole commodity sector seemed to be considered as a market phenomenon. Demand goes up, price goes up, magic happens, and the problem is solved. Not a series of finite, non-renewable natural resources that had engineering bottlenecks in extraction. That was my world in Australia, the mining industry, research and development, and how to mine more efficiently. Assumptions were being made regarding mining, smelting, and recycling in terms of industrial capacity to deliver the required volumes of metals. And in fact, the required volumes of metals didn't seem to exist. Basic questions like how many cars were there in the global transport fleet, everyone just looked at me strangely as there was no discussion there. And so it was possible at some point in the near future, and this is what I made the case to GDK management, the European captains of industry would turn to the European Geological Surveys, GTK in particular, and ask the following question: why did you not tell us of the mineral supply shortfall? Because from my time in Australia, that shortfall was apparent to anyone who actually worked in the industry, who actually considered if we had to expand the mining industry 1,000%, could we do it? The answer is no. So fossil fuels becoming unreliable. And so we need the after oil plan now. The reason that this slide is here is we may actually have peak oil in November 2018. And we're an oil-dominated society. So here we are possibly on the other side of peak oil, and we still don't have a credible feasibility plan to phase fossil fuels out. So far, the global strategic decision-making adopted by most nations around the world, there's been a lot of talk about phasing out fossil fuels, but so far it's all been looking at carbon emissions, generally associated with climate change. At no time are we talking about the quality of resources we have left or what is required to build such a system. So I developed a completely different way of approaching this. I've been thinking about this for some time, and I've been sort of considering how do I actually communicate what I'm seeing in a form where it's understood. And all attempts in the past have been put in a form that could be dismissed as too abstract. And I had to get to the point where I could actually say to a politician, you need to commission this number of power stations, and you need to manufacture this number of cars and this number of batteries. Go. And so what I looked at was what, instead of actually predicting what might happen in the market next year or the year after, what would it take to fully replace the existing system as it is now? And in theory, this is some point in our future. Like I remember sitting in a Brussels meeting in the European Commission Central Building and listening to the European Central Bank CEOs say that fossil fuels will be completely phased out by 2030, 100% phased out. And it really did struck me as these guys were making decisions for everyone else based on very little information. And in Australia, we call this arm waving. And arm waving can be fatal for companies. Whole projects can go down if they have a very poor data foundation. Not just one or two people lose their job, the whole company can go down. So I looked at what would it be to replace the existing system. I picked the year 2018 because that was the most recent year of really good data. And I mapped it out and I worked at how big was that system, how much of it was fossil fuels, what did fossil fuels do, and what would it look like if we completely substituted all fossil fuel systems with technology that's on the market at the time. So the key findings were as follows. So this is the global system. I wrote a short report on this. That's a joke. Sorry, guys. It ended up being 1,000 pages due to the review panel asking for extra stuff to be included. So I will show you what's called the hybrid where all energy policy systems were put together. 6 scenarios were developed. Each one was to represent a policy. So scenario F So first we map the system, oil, gas and coal, and they're the basic jobs that those three fossil fuels gave us. First was the self-propelled vehicles. Up until about 2018, all studies I looked at focused entirely on electric vehicles and passenger cars. Passenger cars represent maybe 20% of the job. So anyway, so all the short-range vehicles were electric vehicles in the plan I proposed. To do that, we're talking about 65 terawatt hours of batteries. Now, all other studies I've looked at have got gigawatt hours of batteries. I've got terawatt hours. What's happened here is the World Economic Forum has badly underestimated the size of the global transport fleet. So this is just the short-range vehicles, anything that stays in a city or has a range less than 100 kilometres. All the heavy vehicles, which is a much, much lesser amount, are hydrogen fuel cells. Now, the electric vehicle fleet's about 1.39 billion, and the hydrogen fuel fleet is around 30 million. But those 30 million vehicles, H-cell vehicles, do most of the work. Aircraft, the only thing that's really sensible to keep us going is biofuels. So if we were to charge the batteries or produce the hydrogen, and accounting for a 10% loss in the power grid between the power station and the point of application, we need that amount of power. So those 30 million H cells will require about 3 times the amount of electricity to function compared to the 1.39 billion electric vehicles. That being said, the hydrogen economy must be given priority over the electric vehicle fleet due to the nature of the work that they do. So most electrical power is generated with fossil fuels. Heating was mostly done with gas, and there was a little bit with steel manufacture using coal. So put all that together, we need that amount of power. Petrochemical plastics, you could take that to bioplastics. There's a lot of pressure being put on the environment, and there was nothing in there to show how much was actually sustainable to pull off the out of the environment. Petrochemical fertilizers had no viable replacement. And it was beyond the scope of the report to actually do anything about that. So put it all together, we need an extra 37,000 terawatt hours on top of what we already have. And if we're not allowed to use fossil fuels anymore, here are our options. The elephant in the room is the stationary power storage needed to manage intermittent supply for wind and solar. And so here's where things get difficult. I'll come to this a little bit later, but this has not been done very well in the literature at all. And I believe that number is actually very conservative. The real number could be as much as 2 or 3 months, which means wind and solar is actually not viable in its current form. More on that later. All right, so here's these numbers graphically. On the left is what happened in 2018 in terms of generation and consumption of electrical power. The non-fossil fuel systems we can keep are down the bottom. The ones in white are the ones we want to get rid of, oil, gas and coal. And the column on the right, is the green column. This is what we want to bring in to replace fossil fuels. So we're talking about bringing in a larger electrical power grid that is considerably larger than the one we've got now, using an electrical power energy system that's not as effective and more expensive and not as capable. So that's probably not going to go to plan. Now, this is just to replace what we have now. This whole exercise was to demonstrate to the masters of the universe in Brussels that their plans for the future were not based in reality. What will probably happen is a new plan will take its place and something else will happen instead. So this does not include coal and gas used directly by industry to generate heat for manufacture. And that's more than half of coal. Like, to make a solar panel, you've got to heat the silicon's wafers up to 2,200 degrees Celsius. At the moment, we use coking coal to do that. So you can use substitution methods to do that. There are things like biofuels or hydrogen. But to the amount of coal we're talking about there is enormous. And so it's actually not possible to actually make that much hydrogen or generate that biomass from the environment. So when we lose coal, much of the industrial capability that we have now for manufacture as it stands now is just going to have to literally shut down, and with no viable replacement. That is actually the subject of future work. So the snapshot is, if you couldn't be bothered reading the report, current plans are not large enough in scope. The cast before us is much larger than the current paradigm allows for. And the whole challenge of phasing out fossil fuels is also larger than first thought. And as I like to say, this is a crap plan and we need a better one. So the global system. All right, well, we need 37,000 terawatt hours. Now, to take an energy split from the IEA, as they actually predicted what will happen in 2050, where 70% of the power grid is wind and solar, we need something like 600,000 new power stations. Put this in context, the existing power plant fleet is 46,000 power stations. So we need 607,000 to replace 46,000. What's going on there? So what that is, that includes, that's just the phasing out of oil, gas and coal. So what's happening there is the effectiveness of fossil fuel power stations is actually much more so than renewable systems. We may have to face the fact that renewable power systems may not be strong enough to replace fossil fuels in their current form. So I actually see the entire renewable power sector as a stepping stone to something else. It's not the final answer for the next industrial era power source. So the power storage buffer is just for wind and solar, but that represents 70% of the power grid as according to what the IEA sees. Obviously, we're going to do something else, but at the moment, we can't get discussion going to what that something else might be, because everyone is trusting blindly what the existing plans are. So it's already said that. And buffer, already said that too. Okay. So here is, why am I saying we need a massive power buffer? Right. So here is solar radiation in Berlin in the year 2015. And this is not rocket science, but in winter we get less solar radiance than we do in summer. But the power system has to balance. It has to generate the same amount of power 24/7 to a resolution of a millionth of a second. So let's say we pick that level there. Half the time, for about 6 months, you've got to, more power is being generated than is needed. So that has to be collected and stored. And then the other 6 months of the year, that power has then got to be released slowly over time. Winter. And winter is also when we need to heat our buildings, therefore energy consumption will go up. So the power buffer would need to collect an excess of power over 6 months, store it for 6 or 7 months, and release it slowly over the following 6 months. So there's 28 days or 4 weeks for wind and solar if we were to look at that same solar radiance. Now, obviously, that's not enough. Now, the Net Zero project in America by Princeton University has got the power storage needed is 5 to 7 hours. And what they're looking at is the day-to-day fluctuations in demand versus power generation. They are not looking at the long-term differences between, say, winter and summer, or the massive changes in wind. And let's look at that. So the United Kingdom Parliament in 2014 did a study on wind, and they found that power production was so erratic that it could not be predicted. And variations produced can last weeks, in some cases months. What didn't help was when they did that study, a massive storm came through. So that is a few months in November 2015, the following later. And look at those swings. If this represents 35% of the power grid, you've now got to stabilize that into a straight line. That's what that means. So here is Sweden, Denmark, United Kingdom, France, and Germany over those same months in 2015 added together, as in this is what they generated with the wind power that they had. And you might notice these massive peaks, followed by these lulls that go for several days. So whatever those, the excess in those peaks has to be got to be collected and then put into those lulls. The size of those peaks, the higher they are, the more power storage you will need. I collected from the Global Energy Observatory is when I looked at operating hours, solar PV units produce power 11.4% of the time of the calendar year in a global context, and wind was around 24.9. As I understand it, engineering has got wind now to the point where it can theoretically get to 33%. Even so, you don't know which 33%. You need a power buffer. So I've actually picked a power buffer, just wind and solar, and this is just to make a point. It's very simple, and it obviously shows this work has got to be done properly, and it actually, to me, shows this is not going to work. In the literature, there was 48 hours plus 10%, where they were looking purely at passenger car vehicles only, and then another reference looked at 1 month for the full system, and I picked 28 days. So according to the IEA split, wind and solar is now about 70%. 28 days is around 2,000 terawatt hours of stationary storage. So if we took the smaller thing, 48 hours, and I can tell you right now, 48 hours is not enough, but we'll use that later. So that's what applies to the power buffer. This is the number of technology units that we've actually need to replace the existing system as it was in 2018. So these are the electric vehicle fleet, 1.39 billion vehicles. That's the hydrogen fuel cell fleet. These are the wind turbines, and they're the solar panels. Wind turbines was assumed to be 70% onshore, 30% offshore. And there's your power storage down the bottom. Now, all of these units, they're to replace a fossil fuel technology system. They harvest renewable energy like wind and sunshine, but they themselves are not renewable. A wind turbine wears out. A solar panel wears out. After about 20 years, they don't work anymore, and they've got to be decommissioned and replaced. And each one's manufactured from metals. Now, less than 1% at the time, I think we're about a little over 1% now, a little over 1% of the global transport fleet is electric vehicles. And renewable power energy is still something like 4 to 5% of the primary energy consumption. So most of the system is still fossil fuel dependent, and the non-fossil fuel system, most of it has not been constructed yet. And as it hasn't been constructed, it cannot be recycled. So the first generation, at least, will have to come from the mining of minerals. After that, can recycling actually deliver such large volumes? And that in its own right will be a problem. So minerals are the new oil. Now remember, all the technology being presented so far works just fine on a small scale. The trouble starts when you actually start to scale it up. So this is a logistical bottleneck, not a technology bottleneck. So that's the end of the first piece of work. The second piece of work was well, now that we know the number of units, how do we actually work out how much metal we will need to produce all this? So the IEA released a report that shared, like, for example, for each of the power systems, what is the metal content in terms of kilograms a megawatt for each of these systems. And this is wind turbines. There's 4 basic wind turbine units on the market. 1, 2, 3, 4. What's the metals in each one? In terms of kilograms per megawatt, we know the number of megawatts, and we know the number of power, number of turbines we need if we make some assumptions about what each one might be. This batteries, what are the different battery chemistries? What's in each battery chemistry? Thank you very much. So then I'm showing you the skimming across the top, the full calculation, and all the full 31 tables behind this is actually coming out in a paper which I'm getting in peer review now. In fact, I might ask VTT to peer review this. So the cathode chemistries in 2014, according to this report, like what the light duty vehicles and heavy duty vehicles, what is the market share going to be? Okay, and so then we can start assigning market share according to chemistry, and we project that onto the number of vehicles. So this is the market share for power storage. We get to this point here, by chemistry, how much different metal will we need? And you can put them all together and sum them all up at the end for each particular job. And so to show this graphically is here. So the red is the total metal to require to produce 1 generation technology units, assuming a 28-day buffer. Blue is showing a 48-hour buffer. This is a log scale. Yellow is our reported reserves, and black is the global mining industry as it was in 2019. The last year before COVID and the last year of sensible data. You might notice there is a massive shortfall. how many years does the mining industry have to operate to hit the red target? If the red target is actually too small, remember 28 days is probably too small. And remember, this is for just the first generation of units, after which they wear out and they've got to be replaced, and we do it all again. So here's the same calculation for the rare earths that I was able to collect at the time. Black is actually what we're actually operating, and blue and red is what we need. And as you can see, we are well and truly behind the 8 ball. You know, 0.1 has got to now go up to, I think that's what, 4,000. Yeah, right. So this highlights a basic problem of where we're going. Here's copper. You can say we're going to make lithium batteries out of something other than lithium chemistry. Good luck replacing copper. From 2020 back to 4000 BC, humanity mined 700 million tons of copper. To keep up with economic growth as it is now, this does not include the electric vehicle revolution. This is just standard consumption. We will do the same in the next 22 years. Now, existing reserves are 880 million tons. So that's about 30 years worth of reserves. There is a pipeline of more deposits coming online, but is that pipeline big enough to service that? No, it is not. In fact, the current copper industry is now shrinking because they're having trouble raising capital to open new mines. On top of that, we want a little over 4 billion tons of copper to manufacture just the first generation of what's around you now. So that's 6 times the total historical quantity of copper mining for the first generation of stuff. I would offer a plan that a fundamental learning that our current plan is actually not going to work, and we need to turn it all around. So mining production and existing reserves are not enough just enough for the first generation, and we need a new plan. Now, there was a request to include biomass and biofuels. So this was actually part of the original report. So there was food, bio-waste, CHP, biofuels, bioplastics, fertilizers, and building materials. Like one of the things I'm fascinated with is what would happen if we built everything out of bamboo and hemp? What would that change? And what we need here is a brutally frank discussion over what's actually sustainable versus what's needed, and in context of what is actually extracted from the Finnish biosphere, but also the global biosphere. So I did this report where what would it take to phase out fossil fuels in Finland, 6 scenarios, each one representing a policy. So policy 2 was all CHP and biofuels were to come out of the forestry industry. And what this showed, there was 2 levels of sustainability, the 2 dotted lines. What this showed was the forestry industry, even if it shrunk to 0, was still not enough.
Simon,
right, so yeah.
3 minutes.
Rock and roll. All right, so let's skip past this then. What does it mean? Current plans are not good enough. And we're seriously underestimated the task ahead. And battery chemistries other than lithium ion will be developed, each one requiring different minerals. Renewables may not be strong enough to replace fossil fuels. Hopes for the future technology breakthroughs to somehow develop more commodity resources don't consider the nature of what minerals that are left. And the current ecosystem has no concept of its dependency on minerals and does not consider long-term concepts like continuous growth in production against finite resources. Look at the finite limits to growth study that was referenced in the previous talk. This report suggests that replacing fossil fuel systems the way we think we're going to do it will not be possible for the entire global population. And there's not enough time or money or resources to do this. And we may be required, therefore, as a significant societal reduction in demand. It implies a very different social contract and a radical system of governance. This is not my problem. Someone else can sort that out. Good luck with that. Inevitably, this leads to the conclusion the existing systems are merely a stepping stone to something else rather than the final solution. And we should probably give some thought about what that other system might be. Ecological reality and biophysical limitations will reassert themselves. So we need a better plan. And this plan has got to be not based in bullshit, which is what the current one is. Tasks to be done. So these are a set of solutions that I have actually developed when people have asked me, what can we do about this? This is the last slide. Conduct a Maslow hierarchy of needs analysis loop in context of what does industry actually need from the point of view of industry and the point of view of all other systems, and then do it in a loop against society as well, and keep going in a loop to see what's possible and what's not. Reorganize industrial value chain around a low energy future and a very short supply chains that are inconsistent in performance. Retool the existing power grid into a network of microgrids that can transfer power between them and can still function if part of the grid is temporarily shut down. That's not the case now. Each grid supports a vital industrial activity, for example, a smelter. Develop an engineering technology that can cope with variable power supply and power spikes. If we can do that, the power buffer may not be needed at all, and a lot of our materials needs actually go away. Plan for a reprioritization of industrial capacity. For example, pyrolysis of rubber and plastics might become more important than they are now. Plan for a systemic merging of energy and raw material feedstock supply in all industrial actions. They're no longer just costs of doing business, but rate-determining steps. Plan for an economy where some industrial capacity can be periodically shut down and started up with damage. That is not the case at the moment. Also, what about a possible period of dormancy over part of winter? Develop an engineering decision-making system that can define whether an industrial outcome is logistically sensible, economically viable to a new set of constraints, for example, using exergy. Should we do something or not? And finally, develop the capability to quickly find substitutions for material products or industrial outcomes as their supply becomes non-linear, unreliable, or unavailable. Evaluate what's really needed, plan to do, and do on a regional scope. Now, this was a system I put together, a decision-making system of how might we do that. And this was the subject of a report. Kiitos and thank you. And that was 30 seconds to spare.
Thank you, Simon.
Thank you.
Thank
you for your excellent keynote, and there are some questions in the chat. Let me pick maybe from here. And this is also something that also Derk could comment on his behalf, that actually we do need energy to eat and move and like lodge and so forth. And now it seems very difficult, impossible to replace fossil fuels. So is it actually then the energy, the root cause of the final root cause of everything?
So we've actually got there was a time when we all grew our own food and we lived in villages and we did everything we needed ourselves. Like you either grew your own food or you knew someone who did. And anything you needed to live, you either made yourself from the local environment or you knew someone who did. That's no longer the case. To live the way we do, we now need technology. That technology has changed or is changing. What's happening here is the commodity sector that supplies everything has been ignored or assumed to be infinite and will always be there. So we're looking at an evolution of that commodity sector, which is where we get our fossil fuel from and our metals. It also is where we get a lot of our biomass products from. So that's going to evolve. We're also looking at a revolution in how we use it. Right. So yeah, and so there's a 1-2 punch we're looking at. One is the energy. Where do we get our energy from? How useful is it? And how do we make sure that we can keep doing it? The second one is where do we get our raw materials from? And the same question, how do we keep doing it? And we've got this just-in-time supply grid that spans the planet, and we're now dependent on people far from here who we like to lecture and even go to war with, China and Russia. How's that going to go? So, yeah, and so what I can see happening is this is like a Fibonacci spiral of complexity that's built up over a century. And now it's going to unravel the same way back to its constituent blocks. And while that system comes apart, a new system is going to take place in a very simple form in the chaos. And it will sit on a nice, strong structure in a very simple form, and it will build in complexity over time according to its thermodynamic limits. That will be energy first.
How would you, Derk Loorbach, comment on this question? It was about the energy. Is that the kind of root cause?
Thanks so much for this presentation. It was a really good one. But my question was mainly on to what extent do you also integrate what I've been arguing for, namely a backcasting scenario? Because you still seem to assume that you take the current energy demand and mainly the primary energy demand, so including all the energy needed for excavation and mining and so on, and try to think how can we make that sustainable. But if we reduce our energy, primary energy demand, if we look at final energy demand, and the structure of renewables is also that we can produce much closer to where it's used, and we radically reduce the amount of energy that we need, then a lot of the problems that you identify might be much less severe.
Right. Now let's hit the one properly. You're absolutely correct, but the people who control our society at the moment, who happen to, for example, run the banking industry, what do they think? They think in terms of growth. Now, they're the ones that control. We have these meetings and we talk all this stuff, and it's all very wonderful. And the purpose of this work was to show those people who run our society at the moment that their plans are bullshit, right? That's the plan. That's to show that this is not going to work, because they believe in not only in economic growth, but an increasing complexity, and the pie will ever increase. They don't like the idea that we might actually sort of be hitting limits to growth, and we might have to look at everything differently. And this never ideological problem-solving thing they've had for the last 50 years, where if they believe something, then it's true.
Yeah.
Doesn't necessarily mean it to be so. So this work is to show that our current plans for the people who actually control our society going forward, they're over their skis, and they actually need to make a new plan. What that new plan is indeed something else. But everything that I've seen most of the time so far has actually been using technology where fossil fuels is a hidden subsidy all the way along. And when fossil fuels become a problem, that becomes a penalty.
Yeah. I think you did an excellent job there.
Thank you.
Certainly going to use it.
How do I set fire to the European Commission? That was the basic premise.
I suggest now, what comes to the time, we move further. We have 7 minutes to go. There's many questions and comments in the chat for you, Simon. If you have time at the meanwhile, please do read and chat and answer from your behalf. And you, of course, all of you can be in contact with each other also later on if there's something that really sparks that you want to continue the discussion and have even some collaboration. Please, we encourage. This is a space for you to also to meet and get these connections. That's one of our aims as well here. But I suggest we move further in a way that, like, I would give the last speech to our one of our coaches as well here, Zeynep Falay von Flittner. Zeynep is going to have give us next week practical 3 days intensive coaching in the format of transition design. So we're going to start what, like you, Derk, painted the landscape for us, that where do we start with the transition? And so Zeynep, are you here? Would you please briefly introduce the next steps? What's going to happen?
Yes. Hello, everybody, and thank you very much for the keynote speakers for the very inspirational and thought-provoking speeches. So if I may share my slides quickly. I had 15 minutes, but I will do it a bit faster now. Can you see everything?
Yes, if you please, 5 minutes pitch.
5 minutes. Okay, so very quickly, maybe I skip some of these. So basically my mission is to bring more design-driven methods combined with systems thinking and transition management and put these things in practice in order to increase our capabilities to look from more systemic point of view and finding some interventions that we can accelerate the sustainability transitions at hand. And we need to build these capabilities, as has been discussed, that we need to move from a more technocentric focus of material component and product level innovation towards socio-technical system level innovation. And that would mean moving from more incremental to radical and from more technocentric to human-centric. And I will be introducing some tools and inspiration from transition design methods to enable this. And as Katri said, that we'll have this physical intensive 3 days workshop next week, and where we will try to expand our understanding with more societal perspective and find interconnectedness between these 3 themes and offer an inspirational space to explore more impactful future research openings. And why, you may ask, like, why do we need 3 full days? We are all so busy, and, is this really necessary? And when I like to highlight that when we work all under pressure, multitasking and juggling from one meeting to another, we get usually this tunnel vision, and we focus on what we know. We cannot access this empathy and compassion and creativity where it's very much needed for these addressing these large wicked problems we have at hand. And unfortunately, majority of the executives in the world right now operates in this mode. Too stressed to look out of the box, too busy to stay with the problem long enough to engage in a deeper level, or to connect with others who may have valuable contributions to the topics from other disciplines. So we would like to give this gift to you from the IBEX program, 3 days, to be able to stay with the same problem and with the people to build connections, and to allow yourself to diverge what you already have defined in your research proposals and look from more societal, holistic point of view to your topics. And I will be holding the space for you to dialogue and collaborate in a new way and support you with some tools and inspiration to kind of help you to discuss. And then it will be a learning experience, so we will also learn from you if that helped actually to open up new research opportunities and connect some new dots that can help you with your research. And very quickly, what we will do is, first in the first day, we will stay with our wicked problem and go to these underlying structures and mental models. Why do we have these problems right now? And the second day, we will use some creative methods to imagine desirable future visions, and that will expand actually your existing written visions from more other parts of the society, how it complements each other. And then the last day, we will build these transition pathway stories to identify interventions, how we can move from current situation to our desirable futures. And we will identify what kind of different new ideas and collaboration opportunities we may find in this exercise. Okay, so that was my quick pitch, and back to you, Katri.
Thank you very much. At least to us, the program management who have been planning this sounds very good and adds up what we have heard today with Derk Loorbach and Simon Michaux. So we are going to go more towards practice with these topics and themes next week. But hey, by the way, is Antti Vasara still here, our CEO? I saw you are online. How does this sound to you? Would you like to say a few closing words for our IBEX 23 kickoff seminar?
Well, first of all, big thanks to Derk and Simon for the presentations. I didn't even dare to try to ask any questions because so many other people couldn't either. There wasn't enough time. But first of all, I think that the whole whole approach with IBEX is fantastic also this year, and all time developing further. The 3 projects have a lot of promise in there. I think today we got both the sort of the almost like carrot and stick then to kind of like keep on working on them and kind of like how to develop them further. But I think the key thing that I took from Derk's and Simon's presentations was also then that we raised the bar with our approaches. So IBEX is the place that where we can stretch the mind and stretch the thinking and do radical stuff. So kind of like go bold there. Many times we have to do customer work and projects for whatever funding agency that where the ambition level is sort of set. So we go with that. But in the own work that we do and in these kinds of things, we can really raise the bar. So you use this opportunity to go bold.
Thank you, Antti. This is a place for learning for all of us, this program. And we would like to warmly thank you all who participated today in the kickoff, and especially Derk Loorbach for your excellent presentation, and Simon Michaux and Zeynep. With all of you, we hope to continue somehow, and we hope that this sparks new ideas for all of us, even kind of like the ones who weren't chosen for the program this year. But the program will be open, and our idea is to have continuously these open discussion with the rest of the organization throughout the year. So we are going to have more speeches, keynotes during the year, and opening up the discussion with the rest of the VTT. So thank you all for the kickoff, and we'll hope to stay in touch with you. Give hand to all, especially the keynotes.